So we're dealing with slant asymptotes. So basically what's going to happen is we want to remember our three characteristics. If we have m is equal to n, then you get y equals a over c as a horizontal asymptote. If it was m is less than n, you get y equals 0 as a horizontal asymptote. And then we always had this case that if n was greater than n, that there was no horizontal asymptote. You remember that?
Yeah.
Okay. So those cases are still true. So with the following example, and that's not the one that I want to do, this is a better one. We're going to try to graph y equals x squared plus 5x plus 6, all divided by x plus 3. So the first thing I like to identify in a problem, I just like to get the horizontal asymptote out of the way regardless. So for this one, I want us to identify what the horizontal asymptote is. So that might help by having our normal function right out here. Oh, that's a C. That's an N. Man, what am I doing? Okay. So we want to identify first our M value, or the exponent in our numerator, which is 2. Because we're going to go with the highest exponent. So the highest exponent here is a 2. And then in our denominator, the lower exponent here on the lower side, that's a 1. Okay, so what we're saying is that 2 is greater than 1 or n is greater than n. So what we're saying is we have no horizontal asymptote. So our HA is gone, not happening. But when that's the case, it's not a horizontal asymptote because we shift it and it's now at a slant. So that's where the slant asymptote kind of gets its name. It's going to be a diagonal asymptote. You'll also see these sometimes called oblique asymptotes, but slant is more descriptive of what they actually are, so I just use slant. So because we have no horizontal, we're moving on to find our slant asymptote.
Do we have a vertical?
We will. Good. Yep, we'll find that one after this one. Great question. Yep, we will still have a vertical. So one of the reasons an honors topic back in like chapter 2, I think it was, we had an honors topic in chapter 2 that was long division of polynomials. It may have been chapter 1. I honestly can't remember. But the reason we had that one is because we have to use it for here. So you're going to want to take your denominator and divide it into your numerator.
I don't remember how to do it.
It's okay, we'll go over it. I promise we'll go over it. Okay. So when we're doing long division, I'll let you get that written down really quick. Okay, open up this window. Okay, so the first way that we start this out is you want to take your first thing and divide it by your first term. So first term divided by first term. So what's x squared divided by x?
X.
Yeah, it's just x. And we write that number up top. And it can be anywhere along this line. I try to line it up with whatever kind of other value it is, but it literally can be anywhere. It doesn't have to line up here. That's not a big concern. After we get that number up top, okay, so after division, number up top, then we actually multiply out. So we're going to take x times x and write that down here, which is x squared. And then 3 times x, write that down here, which is 3x. Notice I'm not writing a plus sign there though. You can if you want to. Good question. So 3 times x.
So we multiply the x on top by the x and the 3.
Good, good. Yep. X on top by the x and the 3. It's almost like a distribution problem there. So I didn't put an addition sign in between, only because I don't want to have to erase it. because we have a little saying that goes along with this. We want to draw the line and change the sign. Remember that? So we cancel those. And then 5x minus 3x is 2x. So that was a full cycle of long division. So next I'm going to drop down my set of garbage 6. I'm going to drop down my 6. So what was the first thing I did?
2x divided by
Yeah, first term divided by first term. So what is 2x divided by x?
2.
Good, that 2 is going to go up top. 2x divided by x is 2, we put that number up top. After number up top, what did we do?
Multiplied by
Yeah, so now this 2 is getting multiplied by x and by 3. X times 2, 2x, 3 times 2, 6. And again, I'm just avoiding putting signs here because I know I'm eventually going to end up changing them anyways. So then we can draw the line and change the sign. Except if it was a negative, you have to put the negative. If it's positive, you don't have to. So those cancel. And shockingly enough, my next two numbers actually cancel. So I get down to 0. I'm going to tell you right now, you will not always get down to 0. It's not always going to work out that cleanly. We love when that happens, but if it doesn't happen, it's okay. You still stop at that point. No matter what, you kind of just ignore whatever numbers down here, whether it's 0 or 10, 25, -6, doesn't matter. We only are going to focus on what's up top here.
Wait, so if we don't like get down to 0, then how do we know when to stop?
Good question. Let's say, for instance, what if I did have a 5 here? The next step would be taking first term divided by first term, right? Okay, so that would be 5 divided by x. Does that give me one whole clean number? No, that's when you know you can't keep going. If you can't divide out the variable in here, then we're gonna have to stop at that point. That's a great question. Okay, so whatever was up top that this divisor is, we're going to say that's what our slant asymptote is. It is y equals x plus 2. Let me write some of this work here. Okay, do you remember how to graph a straight line? Not a straight line, a linear function.
Oh, like, is it like y equals mx plus b thing?
Yes, yeah, okay. So my m is my slope, x plus b, my y-intercept. So what we're saying is we start at 2 on the y-axis. And remember, this is going to be an asymptote. So don't try to put too much line here because it needs to eventually be a dashed line to represent an asymptote. So my slope is a 1. So you're basically going up 1 over 1, up 1 over 1, up 1 over 1. And let me keep going. Down 1 over 1. And then I can kind of just keep going. So I'm awful when I draw these. Like you can already see, like I have this nasty little curve here. I'm dirt terrible. Like I can't do them in a straight line. And that's the one super big downfall. Of course, when you're not using actual graphing paper with this, but even when you are, it can get complicated. Your function's not quite as exact because there's going to be a lot of human error in drawing this in a dashed line. So if you come to the fact that like in the very end, and you're trying to find x, y points, if one's like just barely over top of your asymptote, it's probably just the fact that it's supposed to be super close to it, but your asymptote might like, maybe I did this a little bit too to the right. And my point was supposed to be right here, but now it looks like it's going over top my asymptote because I just did a crappy asymptote.
Wait, so how did you get 1 over, like up 1 over?
Good. So this is kind of like a y equals mx plus b line. B is your y-intercept, m is your slope. So there's kind of just enough like that's not an imaginary one, but it's a 1 out there that we don't have to put. So we know our slope is 1 which slope goes rise over run. So 1 over 1 is rise 1 over 1. Rise 1, run 1. So how do we find vertical asymptotes then? We found our slant, you know, there's no horizontal. What about vertical?
Is it the x plus 3 equals 0?
Yeah. X plus 3 equals 0. Solve for x, you get x equals -3. So I put that dash line right there. And then you just have to go build that XY table like you normally would. So you can choose 2 to 3 points on the left side of your vertical asymptote, 2 to 3 points on the right side. I would suggest, this is what kind of grows pretty easily. Maybe typing them into a calculator. Let's see.
I have like such a hard time typing it into the calculator though.
I
It's like
know.
all the parentheses and then you can get multiple answers.
Yeah.
If you put the parentheses wrong.
No, I totally agree with you.
You guys get the laptops?
Did.
You like them more?
They're thinner. The battery lasts finally, because if that one unplugs, it doesn't have battery at all, so it just shuts off. I know, which is super scary. But the audio on them is definitely not as good. Like, if I'm not standing right here, you can't hear me. So we got these little microphones, but the battery life, like the little like clip-on microphones, like clip onto your shirt,
Oh, yeah.
but the battery is, like if you put like 2 AA batteries in there, they'll be dead in like 2 days.
Wait, how long have you had it? When did you get it?
Let me think, when we got back from the first closure, so that was like after Thanksgiving, I think, when we got back from that one, so sometime last semester. Okay, this is graphing super weird in my calculator.
I think something's wrong with my calculator, or probably me. But when I like put in the stuff yesterday, it'd just be like a straight line down. It'd be really zoomed in. I'd hit like zoom out. And
Yeah.
it'd stay the exact same. And I'm like,
Weird. It could be only maybe graphing your asymptotes too.
yeah,
That
I
could
was
be a
probably
thing.
doing something wrong.
Yeah. But when you do this, you're gonna end up having, it goes, I do know that they're super huge numbers. But the XY table is, again, just plugging in numbers into here. So that's how you get like a little bit different curve. It's gonna be a little bit more confined. So instead of having like a corner, you end up having this like V shape instead.
Oh, okay.
And all of them can look a little bit different, because think about this slant's not super slanted, but if it was like way over here, then it would have like a tiny little space to come down and be in.
Are we doing the XY table or no?
We're not going to for this part, just because it's gonna take so, and these numbers turn out huge. But do you guys want to try one on your own? Okay.
This is the only part of the sentence as the big one.
Yeah, this is it.
Great.
Go.